Hi, I'm Jordan.
And I'm Kit.
Welcome to Starry Time, where stars plus lines
Equals stories.
Today we'll be moving on to the second constellation of Season 2, Quests and Curses! For this month, we'll be exploring the constellation Cassiopeia, the seated queen.
This week's episode will be focused on the astronomy and other cosmic background of this constellation.
Well, I've got some good news about this one, Kit.
Yeah?
Cassiopeia was one of the great. Great. 48 constellations identified in Ptolemy's 2nd century Almagest.
It is very good news.
I'm happy to be the one to inform you. Cassiopeia is the 25th in size of the 88 IAU recognized constellations, and unlike other constellations we've discussed so far, Cassiopeia is actually a name, rather than a Latin word for an object, an animal, or another noun.
Yeah, we're full on in proper noun territory, and we'll be here for the next couple of constellations.
Spoilers!
We'll talk more about who Cassiopeia was next week, but for this week, let's just say she's a mythological queen sitting on her throne.
Now that we've got a little background, let's talk about what this constellation looks like. What were your first impressions of this constellation, Kit?
This is a constellation that I know very well. I can find it in the sky with great ease, and I'm sorry to say that it looks just like a W. It doesn't look like anything else. There's nothing human-y about it, and it's a W. Could you get to anything other than W?
No. W seems to... It was so obviously a W, I started comparing it to W's of different brands that already exist. Like, is this the Western Union W? Is this the Walgreens W? So I was trying to take it with a little bit more specificity. It kind of looks a little bit like a little lopsided W. But yeah, it could also be like a very strange staircase that's poorly designed. But more than anything, yeah, at best, it's a throne if you're really generous.
Yeah, you have to be really generous and it'd be sort of sideways. But yeah, it's definitely just got W energy.
So you mentioned that this is a constellation that you are very familiar with, and you can find pretty easily. This is probably because it's a northern constellation, and it's high in the night sky. It's also circumpolar for kids like us that grew up in New Hampshire. In other words, it circles the North Celestial Pole, and from northern vantage points, never sets below the horizon.
Exactly. So it's just always up there in the night sky, and it is circumpolar for folks even at 30 or 35 degrees north latitude, so that's for a lot of folks in the US. They'll see this in the night sky.
More technically, Cassiopeia has a right extension of 22.57 hours and a declination of 77.69 degrees.
It's between the constellation Camelopardalis and Cephus. And so if you can find the Big Dipper, you can use the pointer stars to find the North Star. And then on the other side, you'll see that W or M, depending on how you're oriented shape. And that's Cassiopeia.
There it is. So now we know where to find the constellation. It's time we talk a little bit more about the stars that comprise it.
So there are 5 stars in the W asterism of Cassiopeia, and the brightest of these is a red giant star with a visible magnitude of 2.24. It has the official name Shidar, meaning breast, and it was designated by Bayer, our good friend, as Alpha Cassiopeiae.
Bayer going 2 for 2 so far in season 2. Looking good, coming out smelling like a rose so far.
But I should note, since we're, very technical, that Gamma Cassiopeiae is a variable star that ranges in visible magnitude from 3.0 to 1.6. So it's occasionally brighter than Alpha Cassiopeiae.
And we remember, of course, as we do, that smaller numbers are brighter on the magnitude scale.
And to make things even more complicated, Beta Cassiopeiae has a magnitude of 2.28. So before more recent calculations, Beta was sometimes reported as the brightest star because they're all pretty close to each other.
I mean, I guess this makes this a particularly good win for Bayer, considering it's quite easy and many people have gotten this one wrong.
Yeah, so Alpha Cassiopeia is 227 light years from Earth. It is 4 times the mass of the Sun, it's a red giant, and it's 45 times the diameter. But it's much, much cooler than our Sun, only around 4,500 Kelvin, compared to our Sun's temperature, which is 5,772 Kelvin.
And that's because it's evolved out of its life from the main sequence star to this bigger but much cooler phase of becoming a red giant, correct?
Exactly.
All right, so that's the brightest star in the constellation. How about we move on to our next segment, Bayer's variable star, where we follow the Greek alphabet to learn more about the Bayer designated stars of the night sky.
So we are up to Zeta in the Greek alphabet.
Ooh, I like the sound of that, Zeta Cassiopeia.
It has the approved IAU name of Fulfu, which comes from Chinese astronomy and means auxiliary road.
Fulfu.
It has, and please, I probably have butchered all pronunciations, so, just the regular caveat that I'm trying, Jennifer. So this star has a visible magnitude of 3.66, and it is a blue class subgiant with a temperature, get ready, of 21,000 Kelvin.
Whoa.
It's 600 light years away, and it's obscured pretty often by dust from the Milky Way. So we don't really know with this star if it's sort of at this tipping point where it might supernova or it might become a white dwarf, and we're just not really sure.
Oh, 2 paths diverged in the galaxy, and here we are right on the brink.
The other interesting thing about this star is that it is probably part of a class of stars that are called slowly pulsating B-type stars, or SPB.
Of course, yeah, the SPB.
Well, I guess it's better than saying a slowly pulsating B-type star. It's very...
Well, I mean, it's shorter, surely, yeah. SPB.
Yeah, it is
rolls
short.
right off the tongue.
So they're exactly what they sound like. They are B-type stars, which are hotter than the sun.
Second hottest, of course, after O-type stars. I'll never forget, of course, Annie Jump Cannon.
Exactly. And they're pulsating over a period between a half a day and 5 days.
All right, so can you tell me, what does it mean for it to be pulsating?
This is a good question, and basically what astronomers are talking about is this observation that the star seems to change luminosity, which is a result of a change in the area and temperature of the star's surface layers. So back in the early 1900s, an astronomer described this as breathing stars, which I think kind of gives it a nice visual of what's actually happening with these stars. They're kind of inhaling and exhaling, they're breathing. I mean, there's actually a lot of astronomy focused on our sun, and there are really cool visualizations where you can kind of see the surface of the sun moving, and you can see all these things happening. I post them sometimes on our socials, but there's really cool stuff out there. If you haven't seen those kinds of things, they're really kind of fascinating to look at. Watching videos of the sun is kind of compelling.
Yeah, no, it sounds great. I hope people check it out on our socials.
So there are various classes of pulsating stars. We don't usually detect pulsation in main sequence stars, but there is some work that suggests that all stars pulsate if we measure precisely enough. And that's kind of the whole deal with Zeta Cassiopeia.
Brilliant. Well, we've added SPBs and stellar pulsation to our ever-growing astronomy handbook together. Now let's take a quick break, and we'll wrap up with our final segment, Gold Star.
Welcome back. This segment is called Gold Star. In this segment, we alternate picking the star or space object in our constellation of the month that captures our minds, our hearts, our soul. So where did you go with this one, Jordan?
Well, we have some familiar friends in Cassiopeia, which certainly caught my attention. There was Kappa Cassiopeia, which sounds like a sorority, but is actually a runaway star. We have a couple of open clusters, and then 2 neighboring emission nebulas called the Heart Nebula and the Soul Nebula.
Very good names, and pictures of these are really stunning.
But I did, in fact, wind up going up with something else. And this one, much like the Crab Nebula in Taurus, is kind of basic. But it's a classic and iconic for a reason. It is SN1572, aka B Cassiopeia, aka Tycho's Supernova.
Yeah, it's supernova talk time. Let's go.
Well, actually, first, why I picked this one is because mostly I just want to talk about Tycho Brahe. I unfortunately know a lot about Tycho Brahe.
Okay, I don't know very much about Tycho Brahe, so I am ready to know.
Well, of course. So he's a Danish astronomer, astrologer, alchemist. He's known for creating very accurate star maps and observations of the night sky. He lived in a castle, and most importantly, he had a brass nose.
Brass nose.
What happened was...
Wait, what do you mean a brass nose?
Well, a nose made out of brass. What happened was, in his youth, or earlier in his life, he happened to get into a duel with his cousin. I mean, they both had a few drinks. They were a little bit drunk, let's be fair. And they got into a very heated argument over who was the better mathematician.
They got in a duel about who is a better mathematician. That's a lot.
It's some real...
And so he lost his nose? What?
Yeah, I don't know if he won the duel, but he certainly lost his nose.
God.
And since we don't really talk about his cousin very much 500 years later, I guess he would say he won the argument. But yes, Battles of the Nerds went hard back in the 16th century. Tycho, like I said, also lived in a castle with a pet moose, which may also have been an elk. Different translations say different things, but a large ungulate of some form, and that would just live indoors with him. Let me specify: this wasn't an outdoors moose or elk. This is an indoor moose elk.
I mean, they don't look alike, elks and moose. So right away, I'm like, well, how do we not know? But also, they're both very large animals. So but I guess if you're in a castle, maybe you have room. It just sounds like he's very eccentric.
Extremely eccentric. Between the moose, the brass nose, the dueling over the best mathematician. I haven't even mentioned the mustache on this guy yet. It's got some real walrus tusks energy coming out from under his nose. It's long and thin, 2 of them. He also, of course, is the mentor of Johannes Kepler, who winds up taking his job at this observatory after Tycho passes away, which is another story in and of itself. I can tell it very briefly. Most versions of it go, Tycho was having a fancy dinner with fellow colleagues, perhaps with royalty, and he liked to drink. That whole getting his nose chopped off while drunk as a youth did not dissuade him from his 2 passions, astronomy and alcoholism. And he liked to drink so much that it's said that his internal organs, perhaps his bladder or his kidney, something burst while at the table, because he had made a bet or he was challenging himself, he's a bit eccentric, to see how much he could drink without getting up to use the bathroom.
Oh, no. Tycho's like, I don't want to break the seal.
He, in fact, did not break the seal of his bladder, but he did cross the mortal plane into history with that iconic life and just as iconic death.
Wow,
However,
that's a lot.
However, during his life, he was a very accomplished astronomer. And on November 11th, 1572, Tycho Brahe had noted, while doing his observations, that the sky looked a bit different. There seemed to be a whole new star in the constellation of Cassiopeia. And this is a huge deal, because we're talking about a time period in which the heavens were not considered to be changeable. They were static. And yet,
Mm.
here they were. One day there's a star in Cassiopeia that had never been there before. Here they are, changing.
Gasp.
Huge gasp. So Tycho, being a knowledgeable astronomer of the time, tracked the changing star first to ensure it wasn't a planet. But of course, other people also saw this happening because this thing was as bright as Jupiter and Venus at various points. Tycho, of course, gets credit in part because of his extensive writing about the new star and because of reprints of his work about this new star, and also because he was already a notable figure at the time. As we know now, this was in fact not a new star, but actually a star that was going supernova.
Yeah, and so astronomers believe this is a type 1a supernova, which is a supernova that involves a binary star system. Basically, what happens is a white dwarf steals material from its companion star and then blows up, goes supernova, when it can't sustain its weight any longer.
Yep, classic when your eyes are bigger than your stomach.
Or you don't want to get up from the table while you're drinking.
Don't want to break that seal. And you blow up because you can't sustain the weight. So this is different from a type 1b supernova, which is when a star much larger than the sun dies.
Exactly.
And there are a couple other types of supernova out there, which we should save for future asterisms.
Yeah, that sounds like a good idea.
Now, Tycho supernova has since stopped exploding, but astronomers still study the remnants of the supernova to this day.
Yeah, and there are really, really cool images from the Chandra X-ray Observatory, which I'll post over on our socials. We're at Storytime Pod on Mastodon. We're still on Twitter. We're on Tumblr, so you can find us at those places. But yeah, it's Tycho supernova. This supernova remnant is a excellent and illustrious addition to the Gold Star of the Month Club. So yeah, and I'm glad to have learned so much about Tycho. Sounds like an interesting guy.
All right, Kit, that's a wrap on the awesome astronomy of Cassiopeia. Next week, we'll be retelling and Constellation, the myths of this constellation.
This has been Kit.
And Jordan.
Sisters, lovers of stars and stories.
And we'll see you next time.
On Storytime.